right, so you see up there it says 226122 NA, okay? You see that? From now on, we're going to have this coming up. That's you, the person who's going to answer the question later. If you're not here, it's so I keep track of, first of all, who's in the class, attendance, and you know who's going to answer. So please pick up the microphone. Whoever sees their name is up there, that's the next person who's going to answer the question that I'm going to ask. And is Denver here? So this is going to happen, see? It goes to the next person, all right? So most of us are not here, so today lots of absence going to be. And if you look at your, is it public? Let me see. Do you have the attendance mark in your grade book? You do have it, right? So I give you 10 out of 10. And as you miss classes, it's going to go, so it's a backwards number. It goes back each time that you're not here. Okay? All right. You're not Denver, are you?
I'm sorry?
You're not Denver.
No.
Okay, good. And you're not Min, I believe. Okay? So I'm going to go through it until I get the first one, and then we're going to start. Yeah, let me make things ready for teaching. This is this one, so come over here. You're not Tina Safai. Huh? Min was you? So you got absent. So I'll start again, okay? So just for you to know what happens. So you look at your name, make sure it's there, because if you don't do it, so, and it's completely random. So it just picks up, there's no order over here. Are you that person over there? Oh, it's you? Beautiful, fantastic. So then you're going to come pick up the microphone, and you're the next person who's going to answer the question, if your name is up there, okay? Sure. We know the drill now? All right, good. So like that, we're going to have kind of a game, and you're going to walk around taking stuff and so on and so forth. So anyway, so we are going to talk about encapsulation today, okay? Essentially implement encapsulation and understand what does it mean, okay? And when we talked about encapsulation, we know that encapsulation is one of the 3 pillars of object orientation, right? Do you remember what encapsulation was? And if you don't know, you simply say pass and we'll go to the next one. Do you remember what encapsulation was? No? No? Okay. No? 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 These are all the people missing the class. And now we have you. Okay. So pass the microphone. So encapsulation. I know, maybe I'm going to even miss the microphone. Forget about it. It's going to take too much time. Okay. So we're going to leave it over here. Everybody shout at the microphone. Okay. Oh, encapsulation. Do you remember what it was?
No, but can I take a guess?
Of course, you always.
So encapsulation, if by the name is space, I'm guessing something that you incorporate all the function within an object, and then so basically everything is working inside that.
Inside that. It's essentially, so we put everything inside an object.
Yes.
The everything that we are putting inside the object, so object, when we say it's the structure, okay? And we say we put everything inside, it means we put the data, all the properties, and we put the behavior, that is all the functions inside that one. That's encapsulation, putting the data and behavior together. So today we are going to work on that, putting the data and behavior together, okay? And the next person who's going to answer the question is Kiarash. Is he? Oh, you're here? Okay. All right, good. So you're the next one. If you take the microphone, thank you. But if you're too far, just ignore it. Okay. So let's start. Let's say, first of all, I want to create an object that's job is to validate an integer. So because the integers that we hold, the value that you hold, those values that you hold are just raw values. Like you have an integer, you put a value in it, and you're good to go. I want that value to be validated automatically, which means I create an entity that is supposed to hold a value, and I want that value to be validated every time it's being set. So automatic. For example, if I'm creating a mark, and I put a limit for a mark between minimum and maximum, say, I'm going to say a mark is between 0 and 100. If I put 120, it's going to be corrected to 100. If I put -5, it's going to be corrected to 0. If I put 50, it's going to set it to 50. So essentially, I want this to be done automatically by this. So essentially creating an integer that does that. So this validated integer that I want to create, I need to create a module for it. So to create a module, the very first thing that we do, we're going to create a header file, obviously. So this is kind of a review on the modules. And I'm going to call it validated int.h. Obviously, when I do that, I'm going to add the safeguards to it, which is if not defined, Seneca validated int h. And I'm going to add a define over here. And that's the safeguards. And obviously, we are writing in a namespace Seneca. So that's going to be my header file. Header file, empty header file, ready to rock and roll. OK? And remember, I told you when we are doing something, before even thinking about what it is, I create the module for it. And that's the module I created. So that's my header file. And now I need to create a CPP for it. So I'm going to say add new item. This one is a C++. And I'm going to create validated int. I think I have it here. .cpp. And that's what I have over there. Obviously, in here, I'm going to include validated int.h. And I'm going to say I am in namespace Seneca. So that's what I'm going to create. I save it. And in my tester program, which is here, I am going to include validated.h. And in here, I'm going to say using namespace Seneca. I am ready to go, to think about what I want to do. Are you OK down to this point? All right, step number 1. Step number 2. Now I need to actually create the object that I was talking about. So that object that I want to create, I'm going to start with a structure. So I'm going to say struct, because that's what we need. OK, so it created my struct over there. But the name is not my struct, is validated int. OK? And I need to fix that thing so it goes to my stuff. So this is the validated int that I have. For this validated int, I'm going to have an integer value. We know that all the variables we put inside our class, we always start with m underline. OK? So m underline value, that's the value I have in there. And I'm going to create an minimum value to validate it. Then I'm going to create a maximum value. So essentially, I have to write code that when this structure is being set to a value, that value is going to be double-checked with the minimum and maximum valid values, and that value will be corrected accordingly. So we are going about to do this using the knowledge that we have in IPC 144. So in IPC 144, if I want to actually start creating if I want to actually set the validated value, what would I do? I would create something like void initialized. And because we started C++, we know that when we create a structure, it becomes a type. So I simply say I'm going to pass a validated integer to this of type reference. Let's say validated integer. And I'm going to pass a value to it, and a minimum value, and a maximum value. And that's going to be my initialization. So essentially, I create a function. I pass the validated int to it. with minimum and maximum and all the good stuff, and it's going to set the values for. Yes?
Passing the whole object and also its individual members.
Oh, those are not individual members. I am passing the reference. I'm not passing the whole object. When I say reference, it means VI becomes a new name for the object. So I'm passing reference of an object and the values the object is supposed to be set to. I'll demonstrate. So, so essentially, when I want to implement this, and because I'm lazy, I'm going to actually, let me just split the window first. Yes, yes. So now, when I create the code for it, this is what it's going to look like. Oh. Okay. So essentially, what I can do over here is to say VI. So actually, let's procrastinate. I'm going to set it up. I'm not going to write it. I'm just going to write. So this is called prototyping. So you create it, you can actually compile it, see if everything's good, and then start coding. So that's what I'm going to do. So the next thing I need to do is to be able to set that value based on the criteria that I had. So I need to write the functionality for it. So when I actually want to set just the value after initialization, the new value is set, and if the new value is not falling within the category, it's going to correct it. So that's my set value. We good? All right. I need to be able to extract the value out of the valid int. To extract the value, that I have to get the value, obviously, right? And this time, because I'm getting the value, I'm not supposed to change it. Instead of just passing, what should we call it, a validated int, I'm going to pass a constant validated.
So why would we even attempt to change it when we're trying to read it? We don't need the constant.
Excuse me? Okay.
We need the constant, right?
Yeah.
Because we're getting the value, reading the value.
Yes.
We don't need the constant. Nothing's going to be changed.
Yeah.
So why did you add the constant?
Because I know I'm a stupid person and I'm going to forget, and I want to prevent myself to make stupid mistakes.
Forget what? We're not changing even with the mistake, by mistake.
So you're the person who's going to have the most buggiest program ever. So,
Really?
yeah. So let me explain what happens. You look at the logic of your application, and you look at the logic of your function, and you look at the function to see what the function is supposed to do. Get value is not supposed to change VI, it only is supposed to extract. Right. Therefore, I have to apply the constraint to it. So you should, I'm sorry, this is something that, actually beautiful question. Beautiful question. It's extremely important. Your enemy in programming is you. Because 2 days after you write the thing and you didn't implement, you will forget it. Like, for example, you want to say, how many times I got a value? So I'm going to put a counter in there, and in get value, I'm going to add 1 to it. Then you are changing it without knowing it. So you should always enforce your logic to what you have. And the same thing, for example, if I want to display it. If I want to display that thing, obviously, it has to be constant, because displaying is to show something. You're not supposed to change it. So you have to enforce it. And this is an extremely important fact that you need to know. Be good down to this point? If I want to add some value, for example, to the amount, that has to be restricted too. So for that, probably I'm going to create something called add to value. So I'm passing, this one cannot be constant because it's adding the value. Or if I want to reduce the value, I'll do this. We okay? Questions at this point? Okay. So if I want to initialize the value, what do? First, I have to set the minimum and maximum. So first, I have to say vi dot minimum value is equal to minv. And then I'm going to say vi dot maximum value is max v. And now I need to set the value, come on, you can do it, to the value that I'm receiving. Are we okay with this? Kiarash, what's wrong with this code? Pass. Next one. I'll go to the next person. Ahmad, are you here? Ahmad Bangura, not here? Absent. Tina, okay. What's wrong with this code? If there is anything wrong with it. You can say nothing's wrong with it, or you can say something's wrong with it.
I don't know.
Muhtasim, are you here? I don't know. Muhtasim, Rafiqul Islam. No? Abdul? Not here?
Full name?
No, it's random. It randomly selects a name.
No, you asked for the full name.
It's up there. You see over there?
The full name of the guy is called out.
That was the full name. Now it's the full name again.
Small window size.
Can you see that? It's big enough for everyone. Okay. Asti? There we go. What's wrong with this code? Thank you.
I don't think there's something.
You don't think there is so nothing's wrong with but it is actually something wrong with it. Okay, let's say in my main, so first of all, let me create a validated int v, okay? And I'm initializing it, right? So initialize, and I'm going to put over here vi 50, 0, and 10. If I have something like this, oh, not vi, v. Can you walk through this for me?
Yeah, sure. So we put V as a reference.
Fantastic. So vi becomes a new name for v.
Yeah, 50 for, let me check, for value, 0 for minimum,
Uh-huh.
and 10 for maximum.
Okay. Does
So-
50 fit in that category? Well, we just
So
said
we
it.
have to check if like the value is between minimum and
Yes. How do we do that?
if a statement.
Actually, you answered properly. I don't know. I'm not going to read that name. Anybody knows that name? That's you? Oh, no. Well, look at the code. Look at, huh?
Maybe something is missing because what you responded to her to say is that you need to check max.
Yeah, because that was the logic. That, by the way, for all those who came late, we are creating creating a record that is supposed to hold a value, but I want that value always to be in order, which means if the value is not within the range that we have to correct it. So if the value is greater than the max value, we have to set it to max value. So putting 50 over here is supposed to set max value to 10, not 50. Why? Because max value is 10. And if I put minus 50 over there, it's supposed to set it to 0. So, and that is not accomplished over here. So this is what we are trying to do. Okay? Not available? So, Shirish, 1, 2. Aryan, okay, there we go. So, what do you think? Oh, thank you for everybody who's moving the microphone around.
Thank you.
How do we fix this?
Fix it.
And use your opera voice. La la la, be loud so I can hear it.
I don't even know, to be honest.
So, first of all,
It
okay.
looks fine to like
Okay,
a grade.
so let me share you something about how we program. Did you see all those prototypes that I have written over there? You
Do we
should
just change
assume
the order?
you should assume they are all written. You should assume they're all implemented. Correct? Now, one of those methods says what? The second one. Second one says
Max value?
set value.
Yeah.
Right? So instead of doing this, I'm going to say
Set value.
now, hopefully, set value VI. When set value is implemented, it's going to correct the value for me. Okay? Mistake that people made in a quiz today is that they didn't reuse the code. You're going to see the quiz. When the quiz comes up, you are supposed to write 3 functions, and essentially, but it's actually 6 functions, but the rest 3 is all reusing everything. So it's like that. Many people wrote the if statement over there where you're not supposed to. You should assume everything is written, and you use those before even implementing it. That's how your brain's supposed to work when you're programming. You look at the function, and that's the focus of your thought, assuming everything else is implemented. And then you program. So when I get to set value, all I'm supposed to think, how to set a value. Okay, so now we're here. So we've done that. Now let's do set value. So I want to write the set value. So what I'm going to do over here will be this. So set value. Now in here, I'm going to say the good old things that I'm supposed to say to actually create it. Simple and straightforward. So essentially in set value, I'm going to write this. Oh, this is M value. Are we good? So I'm saying, hey, the new value, if it's less than minimum value, then set the value to minimum value. If it's greater than our max value, set M value to max value. Otherwise, set the value. So in this case, V will be set to, so let's call it V1. And I'm going to put over here V2. So if I say initialize V2, 10, 20, minus 10, and 30, then this is perfectly valid, and the value will be set to 20. Are we okay with this? We good? All right. So let's do the rest of the stuff, and the next person who's supposed to answer will be Razin. Is Razin here?
Yeah, he's right here.
Okay, there we go. Oh, it knew that you're there. Okay. All right. So let's, so what I'm going to do over here, I'm going to create all these things so I don't have to do it one by one. So I'm going to say over here, create definition for this one. And create definition for this one. This is actually a good practice to create the empty functions so you can even compile and run it. Of course, it's not going to work properly, but what you implemented hopefully will. All these automatic stuff can be corrected. So I have to go, because this is a new setup, I haven't set it up, but you can go to in autocomplete and mention that I want the curly brackets to be where. And so it should follow your essentially setups. So To get value, to return get value, it's very simple. Return m value. Oh, sorry, vi.m value. Okay. Display is to display the value that we have. M value. Okay, as you see, I don't have cout. This is how you include. So you don't ever include anything beforehand. You write, and when you see it's needed, now I'm going to go up here and actually include what I want. And all your standard includes should be before the thing. So in here, I'm going to say include IO stream. And because I'm not in a header file, I can say using namespace std. You know that you cannot use using in a namespace. And that's that. Add to value. How do I add to the value? Razin, how do I add to the value? If you want to add to the value, how you do it? And be careful when you're if the value that is added causes the value to go higher than max limit, it is supposed to be reset back to the maximum limit. So how would you write it?
So we're gonna add it first, and vi.val. Gonna add it and check if it
Crosses, and then you're going to set it. That's perfectly good. There is absolutely nothing wrong with that.
Yeah.
But Nancy is here? No? Ali? No? Isa? You're okay. Alan? Oh, yeah. I hope that you understand. And Denver? No? Vishal, there you go. So there is a better way. What do you think we need to do? Remember I said reuse code? Do we have a function that can do that for us? It's a little tricky. It's a kind of trick, but.
We can use set value.
Yes, we can use set value. So what we can do over here, so instead of, Rosham is here? Oh, there you go. So if I want to actually, I'm going to say over here set value. And then I'm going to say what? So the value is supposed to be added to the value of vi, right? So I simply say vi.mValue plus amount. Done. Reuse your code. And why is it given? Oh, yes, 2 arguments, and vi, sorry. Yeah, all right, thank you. All right? So I'm setting the value, as easy as that. And if I want to reduce the value, I'll do the same thing. So set value, vi, and vi.mValue minus amount. Again, your solution was perfectly good, but there's always better one. Why it's better? Because if 5 years from now you change the logic somehow to set the value, you don't have to go look for it in 10 different places and see where did I add value. You simply change your set value, automatically everything's going to get updated because you are reusing your code. Are we good? All right. Yeah, so now we can actually write some main program to test it. I don't need IO. Oh, I do need IO. I thought I don't need IO stream. I do. So now I can test it like this. So initializing it to that value, then add to the value, then display, then add to the 40 to the value, and so on and so forth. So when I run the program, obviously it's going to run, and we're going to have the result happening over here as follows. Okay? So it's going to set everything. So as you see, it's passing 100. It sets it to 100. It goes below 0. It sets it to 0, and everything's fine and dandy. Are we okay? All right. So I'll save everything. And I'm going to save this one as validate int 1, save. Oh, that was CPP, right? What happens? Cancel, cancel, cancel. Yeah. .h and main .cpp. Okay, so I'll close everything, close all tabs, and reopen this one so we can do modifications. Are we okay down to this point? Okay. What was encapsulation again? Do you remember what encapsulation was? What is the definition of encapsulation? Pass?
Pass.
Pass. Oh, oh. Encapsulation is putting the data and behavior together, which means here, putting the data and behavior together, essentially it means that if you're sick, don't touch it. I'm joking, I'm joking. Do it. Okay, so putting the data and behavior together, that's what we want to do, okay? Unlike C++, we mentioned that you can actually have functions inside the structure. So in here, instead of having these things out, I can actually have them inside the class. Okay? But if you recall from IPC 144, when you define variables above functions, those variables become available to all the functions, correct? So it's because they're all in the same scope. Therefore, these variables will be known to the functions. Also, the function is inside the object, correct? It doesn't need to receive a reference for it because it belongs to it. So all the references will go away. So essentially, when I'm receiving val, min, and whatever that I'm receiving, what I'm going to do, I'm going to say mval is equal to that. I don't need to mention vi's because it's inside of it. It has access to it. The same thing over here. Okay? Now, this is a tricky one. Yes?
So say we have an object vi, we could just directly do vi.initialize.
Let me show you. So we change initialize, right? So because now initialize is inside that, you have to mention that this initialize actually belongs to validated int. And obviously, I'm going to remove this. And then you don't need to have vi anymore because the function is inside that. You follow? And the same thing for set value. The set value over here it will be inside validated int. Therefore, it doesn't need this one, and doesn't need vi, and doesn't need this.
Is there a reason this version isn't preferred? You can use either.
Give me 2 seconds. You were saying?
I was saying, is this version like preferred, or
If you use the other one, you have to go back to IPC 144. This is the essence of object orientation. Okay. The good thing about object orientation is that each object knows what it does. You don't need to pass the object to some function standing somewhere. Were you here when I was talking about, like, close your eyes and I said hello and people got scared and stuff like that? Do you remember that? You weren't here?
I don't think so.
You don't think so? Okay. The whole point of any object in the world is that they do similar things. You have a computer, right?
Yeah.
It is displaying something, correct?
Correct.
She has a computer, right? It is displaying something, right? So your computer dot display is displaying something to you. Her computer dot display something to her. But the value that is displaying depends on what is on your computer and what is on her computer. That's the essence of encapsulation, which means each object has access to its own data.
So that's why we can't pass by reference.
Not the can. You don't need to because you're in it. If your head itches, will he itch his head?
That
No.
depends are we passing reference?
You're not passing reference to him. We are two individual people. Do you have tattoos on your arm?
No.
Why? He made one on his arm. Because it was his arm that got tattooed, not yours. You follow what I'm saying? It modified that, but yours remains the same. Got it? All right.
I have a question.
And I have an answer.
For sure. So, for example, do you have using namespace STD at the top there?
Mhm.
But in your Seneca namespace, we don't, because you put the using namespace at the top, we don't need to use the
STD is scope resolution anymore. That makes your life easier. And by the way, the set function that I called over there, I'm calling it incorrectly. Because now set function is part of VI, it doesn't need VI anymore. I'm just going to say, set yourself to val. I don't need to say, hey, so that's that. And the same thing over here for all these things. So for get value, all these display stuff that I have, all these stuff will actually be part of. So I'm going, oh, the one that I was saying that is tricky. Like this one is a little tricky because if I remove this one, how do I make get value not change the owner? It's very easy actually. If that's the case, you simply write a const after the name of the function. That means, hey, don't change your owner. Your owner is not supposed to be changed by you. So if by, of course, I'm not going to have VI over here anymore. So by default, if I say over here, say m max value is equal to 20, it's not going to allow me to do that. It's going to tell me expression must be a modifiable value. You cannot change the owner. That enforces what we've done with passing the thing. Are we good? Are we okay? All right. So same thing for all the rest of the stuff. So let me see if I can actually get the code from here. I had it somewhere. Oh, yeah, I have to do some modifications, but that's okay. So I have get value. I need these. So Control C. That's that. And the only thing I need to do, display over here, I have to fix these. So display is constant. This will be const. This doesn't need VI anymore. And this doesn't need VI anymore. You asked the question. You asked the question before, so we can do both. When we study further, we'll see that sometimes you need to.
Do it the previous way.
Yes. Okay? That is how messages are passed between classes. So let's say you want to say hello to another person. You will have a function called hello that as an argument accepts another person, says hello to that person. So sometimes you need to pass it. These are, or will come up soon. So remember the Remember this word, helper functions. In future, you will see that helper functions actually require that. But helper functions are very, very dangerous thing. We need to know how to use them. Okay? Anyways, so now these values over here, I need to change them to m value. Okay, so now, as you see, I have my class encapsulated with data and behavior in the same place, and my main now will be almost identical to what I had before, but the difference would be that instead of passing V to different things, I'm going to say, hey, VI, initialize yourself. VI, display yourself. VI, add 30 to your value. VI, display yourself. And so on and so forth. VI, reduce the value by 90. So I'm actually telling to VI how to do the work. We good? Are we okay? And we run it. It's not still object oriented. What did I do wrong? Value is not a member. What value? What? What is this? What did I change? Did I change the values? What is this?
Declare the scope resolution.
I want to demonstrate that
What would happen?
this is m value, yeah. Okay, so I'm going to remove these for now. Delete, 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 delete. Or comment. Let's comment it. Okay, and run it. Okay. So now we're going to come to the example that I always give to the class at this time. And that kind of explains everything. Let's say this lady and I are standing in a coffee shop that I wanted to go and we didn't have. Okay? You don't know, but we're supposed to go to it. It was closed down. Anyways, so we are standing in line. I'm in front. She's standing behind me. Okay? And we get to the point that I want to get the coffee, and I see I forgot my wallet. And I'm going to say, shoot, I want to look back over there. She's my student. She knows me. Can I borrow $1.50 to get coffee? I'm going to give it back to you. Probably you will give it to me. Why? Because I'm the teacher. Probably, I'm going to get some extra marks later on. So whatever it is, we are friends. So she's going to give me the $1.50, and I'm going to pay the coffee. Then we come over here. I'm going to take one. Good. We good? Now rewind. Go back. Now I'm over there, and she's going to give me the $1.50. Okay, this is your situation, by the way. Okay, so you say it works. Okay, so what I'm going to do in here, I'm going to get over there. Oh, I don't have the wallet. And I'm going to come close and put my hand in her pocket, look for $1.50 in there. What's going to happen? Yeah, slap in the face probably, right? Why? It works. She has $1.50. I want to pick it up. I'm going to give it back to her. What was wrong in here? Invading privacy. Okay? So although those values are there and it's working, right now I can put my hand inside VI's pocket and change the value to 150 manually. And when I run the program, you will see that it actually is 150 in a range of 1 to 100. It's minus 50, so it gets screwed up. So the problem is that even if I am what do they call those people? Pickpocket. Even if I'm a pickpocket and I am her brother, she's not going to mind if I put my hand in her pocket and pick up $1.50. She's going to be surprised when she's going to go get the coffee because she says, there's no money. I had $150. What happened? Okay? So it should, it doesn't matter that you can or you're allowed or it's okay or not. To keep things object-oriented, so encapsulation craves privacy. So how do we enforce it? We'll go over here and we'll say, hey, these things, whoa, not there. We're going to say, hey, these things are private. Don't touch them. But these are public. Now, it's going to tell you, hey, you're trying to, where is the error message? Member yada yada declared in something, something, something is inaccessible. You cannot touch, you cannot put your hand in someone else's pocket. If you want, ask for the money. Use the methods to access the value in a controlled way. Got it? So like this, the only way that I can set a value is to call set value. Therefore, if I'm incorrect or I'm doing something badly, it's going to correct it. And therefore, the object remains in a valid state at all time. Are we good? Okay? All right. Now, in C++, a structure is an object, as you saw, that is public by default. Everything is public in a structure. Okay? We don't use structures much. We use class. Class is exactly a structure, but everything's private by default. So if I don't write that private up there, those will be private anyway. But I'll do it anyway. I'd like to see things the way they are. I do not like to let stuff stay as default because it's like it's as if you're commenting. You're emphasizing that these are private. So from now on, we use classes, not structures. Okay? Same. This is actually an interview question. They're going to ask you when you're going to do an interview for hiring you. They're going to say, what is the difference between a structure and a class in C++? You have to say they are identical. The only difference is that one is public by default, the other one is private by default. Am I good? Okay? All right.
You don't have to say private.
Huh?
Class, you don't have to say private. Because everything's private by default.
You don't like to. You don't have to say.
What should we say?
I do. That's my stuff. Because everybody knows class is private. But I always like to flag things. I don't know. It's something that I have. And you will see many people do this, actually. Many people like to write the attributes after. I have no idea why. Then you have to, because if you don't put it, they're going to be public, right? You can put it up and down. They don't have to be in a specific sequence. You can put it. So if you're putting it like this, if you put the attributes at the bottom, which I do not do, you need to actually mention they're private because. And there is another common mistake that people think. People think attributes are always private and methods are always public. That's not the case. Sometimes you have methods that are private. They're not supposed to access because they're just tools that are supposed to be used inside validation. You don't want other people to use it, okay? And sometimes you have attributes that are public because you don't want to have any regulation on it. It doesn't matter what value. If I had an integer and it wasn't important what is the value, what kind of value it's going to have, or it's going to be, I'm not supposed to enforce any rule for it, why do I create a method and bloat my code? I'm just going to leave it, make it public so they can use it, right? Okay, so now these are not possible, so I'm going to do it like this. And save this. So we're good down to this point?
It doesn't matter if you mix the STD with the not dots, the two columns together, the one at the bottom that you just.
You're talking about this? Oh, public, yeah, you're talking about, yes. In main, you don't have such a thing. Oh, you're talking about this?
At the bottom. So you have the STD, CL.
Oh, yeah. It's redundant. I shouldn't have written it. Yeah.
If you write it, it's not a mistake.
No, nothing's wrong.
You
No. It's as if you tell me, Fardad, can you explain that? Or you say, Fardad, who is in room 2100D, can you explain that? It's the same thing. Oh. Actually, let me put this back up. I don't like it here. We still have a bit of problem here. The problem is what if somebody does this?
We can set it to 0.
Because I didn't initialize it, correct? That's not right. You shouldn't be able to say initialize, and it's not initialization. By definition, initialization is setting at the moment of creation. So I need to be able to set VI at line 7. That is initialization, not this. This is wrong. That's why we have a specific type of procedure. They are not functions. They look like functions, but they are not functions. And the biggest mistake is that you think you can call them like functions. You can't. We have specific procedures that we can write in a class to trigger something when the class is being created. For example, in here, I want something to happen. Why it keeps coming down? Go back up. So how do I do it? First of all, I do not want anybody to be able to initialize this other than me when needed. So that initialize goes to private part. Because I want to initialize it. I don't want people to call it initialize. That's wrong. You cannot call initialization. That's just setting. That's set value. That's not initialize. Okay? Now, how do I trigger that? You can create a procedure we call constructor, which essentially is a procedure with the name of the class, but doesn't have a return type because it's not a function. It doesn't return anything. It's constructor. Its job is to construct an object. Now, when I create a constructor with no arguments, that essentially means it's supposed to now give me some error that it's not set, but it's okay. I'm going to come over here and set it up. By the way, don't trust IntelliSense. It's sometimes a little too slow. Okay? So I'm going to create the definition. As you see over here, the constructor is exactly like a function. I can do whatever I want to do in it. So what would I do in it? I'm going to say initialize. Initialize. I'm going to say value 0 and say by default an integer should be between values of, I don't know, minus 100 and a positive 100. Whatever. Whatever I think an initialization is supposed to be. We good? So if you don't mention anything, it's going to be between minus 100 and positive 100, and it's going to have 0 in it. That's my default. That's how it's going to be defaulted. Now, if I come over here, and obviously I need to be able to initialize it properly too. I need to be able to say this. I need to pass the 3 values to it. So you can overload the constructor like you do a function. It doesn't matter. Okay? So now if I actually create this, I can again call initialize in here. How do I initialize? Initialize val m minimum value and maximum value. There we go. Now if I go back in here, I can create, first of all, this you cannot do. It's not going to allow you. It's private. You can't do that. But now I can actually say, let's say in here I'm going to create VI, and in here I'm going to say 50. You can actually do it like this, 50, 0, or 100, and 100. It's the same as this or this. These 3 are identical. These are pretty new. So these are 3, 4, 5. This is what we teach in 3, 4, 5, but I'd like to let you know. Remember that universal type of initialization I told you? Recently they add this. So the old C++ is line 9. Okay? New C++, they all do it like 7. It's the same thing. Meaning is exactly the same. No difference. Okay? Are we good? Did I just say meow? Yeah, okay. Okay, new C++. Okay? So now, in here, I can have v.display with absolute. Why is it doing this? It says uninitialized memory, so it didn't detect that I actually wrote a constructor, but it's wrong. Anyways, so I can have validated int v, and I can go v.display and vi.display. Oh, I already have vi.display. Let's remove that. We have it at the bottom, right? So now when I run it, you will see that at the moment of creation, it actually calls it, and everything is set perfectly. So the one that I did not mention, it's 0 between minus 100 and 100, and the other ones are set exactly as they would. These are called constructor. Remember, you can never, ever call a constructor, ever. Okay? Let's say I want to have another constructor just to set minimum and maximum value and default the value to 0. So I can create the third one. I can create over here a constructor like this. I can say, where is the thing? I can say, for example, validated int I'm going to say int minimum value and int max value. And I want when I do this, to set the value to 0. So what am I going to do? I'm going to reuse my code. I'm going to say validated int, and I'm going to put over here 0, min v, and max v. Give me a second. Kyle, you're here? Is that correct? Line number 15, line number 16. I am reusing the other constructor. I'm calling it, so that constructor, thank you. So that constructor is set.
Sorry, my eyesight's really bad.
Okay, give me a second. First, I'm going to do two things for you. First, I'm trying to find where the devil is the, how do you? Oh, it's back there. And I'm going to make the font bigger. Did I ask anybody's light sensitive? We don't have light sensitivity? No? Okay.
that tablet in the front there?
What is going on? Nothing's happening.
It doesn't slow.
It just dims?
Isn't that tablet in the front?
Nah, that I touched that one before. It didn't do anything. Anyways, I'll make it bigger. Sorry. Anyways, the person without question, please keep it for a second. We'll talk about it in a second. So, is this okay? So in line 16, I am calling the other constructor to save time. Looks good?
You can't call the instructor.
You can't. It won't give you a syntax error, but you can't call a constructor. I just mentioned it. So when you write this, you know what's going to happen at line 16? What does constructor do? It constructs, right? So at line number 16, it's going to create a nameless validated int and dies at 16.5. It has nothing to do with your object. It's just building a nameless object and it dies like that. So you cannot call a constructor ever, ever. Remember, you cannot call a constructor. Later on, we're going to learn when we can. So, but for now, again, that's why we have that private function. That's correct. You cannot call a constructor. Remember that. Okay? We good? All right. Is Darian here? Darian 1, Darian 2. Oh, very good. All right. So I'll get it to you. Well, or you just pass it by. Pass it. Thank you. Okay, so now we have a constructor and life is beautiful, everything's good. Now, what if I want to have some kind of a title for this? What if I want to have some kind of a, so I'm going to put this one at 3, so I'm going to go over here. That's 3. You cannot compile 3 because the name of the header file is different. You know that, right? Because now I changed the name of the header file, you have to change the include over there too. I'm just writing it for you to see the steps that things are done. The sequence of things that happen so you can actually see the progress. Okay? So let's say I actually want to have a title for this, like it's a mark, it's a price. I want to have something for it. If I want to do that, then what I need to do is to actually change my validated int as follows. Set value, set value is good. So I created a character title because I don't know what is the size of a title. I want to do dynamic memory allocation. I don't want to do it that way, okay? And so I don't. So when I'm initializing, I'm going to initialize it with a title parameter, minimum and maximum value, and then I can have 1. So as you see, line number 15, I'm kind of shortcutting. It's a default constructor. Default constructor is a constructor that has only one argument or no argument constructor. So line number 15 is a no argument constructor and one argument because it has default value. So if you don't put anything, it's still accepted. So those are the two that I have. So I need to have, and I'm going to have a release function that releases a dynamic memory allocation when not needed. So let's put those things over there. So I need to change initialize so that is my initialize. That's my initial. So what does initialize do? Sets the title to null PTR. If the title parameter carries something, it's going to, for strlen, I need a CS string. So I'm going to go include C string. OK? So I don't want to, yeah. So, so I'm going to get the length, add 1 to it, then copy everything to it. So that's literally dynamic memory allocation. So to the exact size, then set minimum, set maximum, and set value. Those are fine. For the constructors, I'm going to have these two. Copy. It's constructor, so these are the constructors. So for constructors, I'm doing the exact same thing, no difference. I'm just going to say get the title parameter, set it like that, and get the title parameter. So I'm just recalling initialize. There's nothing extraordinary in here. We good down to this point? And then I'm going to need to have the release function created. Now, release function is the one that is going to release the memory. OK, so let's put it down here somewhere. There you go. So I simply say delete m title and set it to null. We good? Obviously, I don't want people to release the memory and screw up my object. That's why my release is in the private part. Are we good? Now there's a problem. If I make the release public, people can do it halfway through the program and destroy everything. They have to remember to do that at the end when object is going out of scope. And that's dangerous. Because of that, we have another non-function procedure called a destructor. Destructor is exactly like a constructor. You add it. So you put the name of the thing, so validated int. Never accepts an argument. It's always no argument because its job is just to kill the object. But at the beginning, to set it as a destructor, you put a tilde at the beginning. This becomes a destructor. Destructor. So the destructor of mine, essentially, what it does is simply releasing the memory. Now, when I write my code, I can comfortably run the program without caring if where is it? So let's come over here. Copy. So now, as you see, I am creating the classes, and each class has dynamic memory allocation. So when the program runs, this is what happens. Oh, I have an error. Let me see what it is. Holy schmoly, what did I do? Already defined. Wait. I have using namespace. Why am I? Oh, because I'm using namespace std. Let's remove this. Let's see if it compiles. No, why is it giving me this? No, it's not supposed to. Oh, I don't have it here. Oh, I'm an idiot. H. Sorry. Okay. Let's do it one more time. Rebuild. Make sure everything's good. There we go. So now let's run it and see what happens. So I'll put this one over here. Oh, and I don't need this. I don't need this. I don't need this. I don't need, oh, mother. There we go. Ah. Oh my God, so much. There we go. And now I'm going to put this one at right. And let's walk through. So it comes over here. I'm pressing F10. As soon as I'm going to press F11 now, because there are no argument, it goes to the one argument with the default value. Obviously, the title parameter will be integer number, because that was the default value for the argument. So it goes over here, and after that, it goes to initialize. And initialize sets the title to null PTR. Title program is set. Allocates memory, does the copy, minimum, maximum, sets value, comes out, and life is beautiful. Now it's going to go with 3-argument constructor. So essentially, it jumps right into the constructor and calls initialize this time with OOP244 mark and the rest of the stuff. And now it shows the default value. It shows the display for the thing. And I think I didn't update the display. I didn't update my display, because display should show the thing. Otherwise, what is it good for? Let me bring up the display. Display, display, display. Yeah, there we go. I forgot to set the display. So I'm going to come back over here. Display, display, display. Yeah, the display is supposed to show the title. And I'm showing it in a safe way. So if mTitle is null, it's not null, it's going to show mTitle. If mTitle is null, it's going to show no title. Okay, so my display is safe. Let's run it one more time. And now we ran it right down to here, right? So I'm going to just put the stop sign right over here, press F5, so it runs everything and stops at display. And then I can continue after that. Now I'm going to display that, integer number value, OOP244 mark value, then set, and everything works perfectly. Now I want you to pay attention to this. When it's dying, I'm going to the end of main, right? As soon as I go to the end of main, VI and def are supposed to die, correct? As soon as I press F11, as you see, the destructor is called. It goes to the release, and as you see, OOP244 mark is being deleted. Remember, objects are like stack of stuff that you put over each other. When you create object A, B, and C, when they are dying, first C dies, then B, then A. It's always in reverse, as if you're stacking stuff and you're picking them up. Okay? So first the OOP244 dies and releases the memory and sets it to null. And then, as you see, the integer number will die and goes out of memory. And that's essentially a destructor. Are we good? This function of mine, this object of mine, is very dangerous. Okay? You can go experiment with it. When I say dangerous, it means it's going to have lots of memory leak. And it's going to crash if you do specific things for it. But I'm doing it just like this, it's fine. Okay? But try passing it by value to another object and display it. You'll see it's going to crash at the end. Okay? So if I do this, okay? And then in here, let's say I'm going to say over here, show valid int. I'm going to say def and show valid int. I'm going to show VI. Okay? If I run the program, this is what's going to happen. Okay? Abort. So, but if I do this, then it works perfectly. Oh, no, it doesn't work perfectly. Let me see why. Because the other one crashed, and it says you cannot, I cannot, because the other one is crashed, the executable is still running. So it cannot update the executable. And I made a mistake over here. I should have made this one const because I'm not changing it. Okay? It doesn't matter. It works, but I'm going to make it. Let's see if it's good now. How do I? It's still the same? Yeah, shoot. Let me see if I can run Task Manager. Where is it? I think it's gone. Let me try it one more time. No. Darn. I want to find the task and kill it. Oh, there we go. Found it. Wait, jumps up and down. Stay with me. And task. Okay, thank you. All right. Now if I run it, it will work perfectly with no error. So remember, you'll find out later on why and how we fix it, but objects who have dynamic memory allocation in them cannot be copied. They're gonna crash. Remember I told you get a 4-colored pen? Do it and do it with ampersand as reference. Do it with reference, and without reference you'll find out why. Okay? So that's that. Constructors, destructors, and that's it. So what I'm going to do over here is this. And I'm going to say, this will crash. And you know why. Okay? Anything else? Let me see if I'm missing something in here. So remember, constructors, they are made using the name of the class itself. You can overload them. You cannot call them. And let me take a look at the notes, see if anything's missing for today. I'm just going to look at the addendum. Okay, so we are doing member operate. Oh. Oh, no, nothing. Never mind. No, we're good. Member functions, privacy, construct and destruction. That's it. Okay. Pardon me? I don't know. I'm thinking. Should I? I think we're okay. Any questions, anyone? No question? So, Chabal is here. And, wow, you're done. You're the last person. So, yeah, so I'm going to upload those things, and those who are not here will actually see that their attendance is coming lower, okay? And we're going to continue doing that as we are going throughout the semester, so you'll know. So I'm going to upload. Any questions, anyone? Suggestions? Objections? Okay, I'm going to stop the recording first.